Any questions for me? Anything that you worked on and anything that you looked at? Anything? Any questions? If not, I would like to work on problems from Trig, chapters 5, 6, and 7. Okay, then. Good. So I'm looking at the end of chapter 5 right now. There is a review section at the end of chapter 5, starting on page 424. So for example, 8b, which is, so this is page 424, end of chapter 5. Tangent of negative pi over 3. That's one problem I would like to look at. Then the next one would be 24. Cosine t equals negative 3/5. And tangent t is less than 0. So let's start with these two. Okay, what do I do first when I'm asked to find tangent negative pi over 3? This is what I would do. I remember the tangent is an odd function. If it is odd, this will be negative tangent pi over 3. I was specifically told not to memorize tangent pi over 3, but I know that this is sine pi over 3 over cosine pi over 3. And sine pi over 3 is first of all, pi over 3 is the third angle in that tiny table. And sine will be the square root of 3 over 2, and cosine will be 1/2. And when I divide, I get negative the square root of 3. This is what I would do. I will apply the properties of odd even, meaning I know that all trig functions are odd except secant and cosine. So 4 are odd. Any function that has sine in it must be odd. So tangent has sine in it, cotangent has sine in it, secant has sine in it, and sine has sine in it. So all these 4 are odd. The only 2 functions that are even are the functions that have only cosine in them, which is cosine and secant. Now for this problem, here I'm given that cosine is negative 3/5 and tangent is negative. So for 24, I have to picture the angle. Here I did not have to, but here I have to picture the angle. Cosine is negative in these 2 quadrants because cosine is measured on the x-axis. Tangent is negative where sine and cosine have opposite signs. So tangent is positive in these 2 and it's negative in these 2. So tangent is negative here and here. The only quadrant that complies with both conditions is quadrant 2. So I know that t or x or theta, doesn't matter, is in the second quadrant. And I am asked, I'm given the information that we looked at, find the values of the remaining trig functions. So this is a typical problem from trig. Okay, so I know that sine t will be positive, cosine t is negative 3/5. I know tangent t, cotangent t, both will be negative. And I know that secant t will be negative and cosecant t will be positive. I already have cosecant. I already have secant because cosine is negative 3/5. This must be 5/3 with negative in front. My next step would be to find sine. If I find sine, then I found the rest of the trig functions. And I do have 3 identities that I have to remember. So here they are. Sine squared x plus cosine squared x is 1. 1 plus tangent squared x equals secant squared x. and 1 plus cotangent squared x equals cosecant squared x. That's what we need to know for now. I will review all the other identities in a minute. So if I have cosine, I can plug it in here and find sine. First I will subtract. So I have sine squared equals 1 minus cosine squared. And I will replace this by negative 3/5 squared. So I will get sine squared equals 1 minus 9 divided by 25. 25 over 25 minus 9 over 25 is 16 over 25. So sine squared x equals 16 over 25. And when I take the square root, I should write that sine x equals plus or minus 4/5, but I will say only positive. So I go back to my list, and I will put sine is 4/5. At this point, I know the rest. Because if I know sine 4/5, then I know cosecant 5/4. And if I know sine and cosine, I know tangent is 4/3 with minus in front. If I know tangent, then I flip tangent to get cotangent, 3/4. And that is done. I would like to look at some graphs. And that will be it from chapter 5. We can move on to chapter 6. So let's graph 32, which is y equals 2 sine x minus pi over 4. Find the amplitude, period, and phase shift of the function. I will add the most important interval, or the interval that we should use to graph the function, and sketch the graph. I would not say sketch the graph, I would say sketch one period. Okay, the amplitude of this function is the absolute value of the number that multiplies the sine. In this case, it's 2. The period is 2 pi divided by this number that multiplies x. In this case, it's 1. So the period is 2 pi. And the phase shift is pi over 4. If I had positive here, I would have said the shift is negative pi over 4. The interval is b comma b plus the period. This is the interval that we would use to graph this function. So it will be pi over 4 comma pi over 4 plus the period of 2 pi. So 4 times 2 is 8 plus 1, 9. 9 between pi over 4 and 9 pi over 4. I'm going to attempt the graph by hand, and then I will check my work with the graphing calculator. So here's what I do. I start at pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8, 9. 9 pi over 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Between 1 and 9, I have 8 ticks, right? So right in the middle, 1, 2, 3, 4, right in here, the function has to cross the x-axis. Also, if this is 1 and 2, and this is 1 and negative 1 and negative 2, and the function right in the middle, right here, it has to go to 2, and right in the middle, right here, it has to come to negative 2. So this should be a complete graph for sine. So this is y equals twice sine x minus pi over 4. So with the graphing calculator, Let's put in y equals 2 sine x minus pi divided by 4. Make sure your mode is in radian. And then let's go to the viewing window. I want the viewing window to show between pi over 4. That's not what I meant. Between pi and over 4 and 9 pi over 4 with a scale of pi over 4. I want to see those ticks in there, pi over 4. I don't care for negative 12. All I need is negative 3 to 3 at the most. And now I'm graphing. Here's the graph. It goes up to 2. It crosses right here in the middle at 1, 2, 3, 4, 5 pi over 4. And this is 9 pi over 4. 1 pi over 4, 5 pi over 4, 9 pi over 4. Right in the middle, 1, 2, 3 at 3 pi over 4. Right here is maximum, positive 2. And here is negative, minimum, negative 2. Any questions? Okay. Now, one other thing that I would like to show, and we can, look at other, for example, 35. We don't have to graph this, but I just want to point out something, just to refresh your memory. For example, y equals negative cosine pi over 2x plus pi over 6. Let's just list the amplitude. So the amplitude is the absolute value of negative 1, which is 1, which means the function will not go beyond 1, will not go below negative 1. The period for cosine is 2 pi divided by the number that multiplies x. So divided by pi over 2, I have to flip that. So it's 4 pi over pi, which will be 4. Now I have to determine the phase shift. But in order to determine the phase shift, I have to pull out pi over 2 in front of the parenthesis, not in front of cosine. That will not be allowed. So from here, I will write negative cosine pi over 2. And let's see what we have left in parentheses. Of course, x. Of course, plus. But pi over 2 times what is pi over 6? 1 over 3. Right. Pi over 2 times 1 over 3 is pi over 6. So then the phase shift is negative 1/3. Pi over 2 times x is this. Pi over 2 times 1/3 is this. And the interval will be negative 1/3, comma, negative 1/3 plus 4. So negative 1/3, comma, this is 12 minus 1, 11/3. Okay, since I started, let's also go look at this graph. So I'm going to say this is a unit 1, 1, 1, 1, 1. So negative 1, 1, 2, 3, 4. It starts at negative 1/3. So this is my negative 1/3. And it ends 1/3 before 4. It cannot be more than 1, and it cannot be more than less than negative 1. Right in the middle, which is here, it will have to have a minimum. However, remember what happens when a function has minus in front? We have to flip it. So the actual graph should be this. Like it's like a vase, right? something like this. But instead, that negative in front will flip the graph over the x-axis. So this is one point, this is another, and this is another. So this is negative cosine pi over 2x plus pi over 6. Let's take a look. Now in y equals, I have negative cosine in parentheses. Be very careful now how you plug it in. So I'm going to use another set of parentheses for pi divided by 2. Yes. Close the parenthesis, multiply by x, and then plus pi divided by 6, and then close the parenthesis. Be very careful. Okay, so now my viewing window will be between negative 1/3 to 11/3, and I want the scale of 1/3. And negative 3 is good enough, but I know it's not going to go beyond negative 1 and 1. So now I'm ready to graph it. Here it is. That's the bottom of the vase, and then it comes back to the top rim. Right in the middle, between this point and this point, right in the middle, it has that maximum. And here, this point is negative 1/3, negative 1, and this point is 11/3, negative 1. And this one is, what is it? 1, 2, 3, 4, 5. 5/3, 1. Okay, I can think, oh yeah. Let's also look at problems 49 through 52. Any questions on this graph? Okay. Okay. Find the exact value of each expression if it is defined. So let's say 50 on 425. Cosine inverse of negative 1/2. And let me remind you a few things here. Sine is considered to be defined between negative pi over 2 and pi over 2, with its values in negative 1, 1. Therefore, sine inverse is considered to be defined on negative 1, 1, taking its values negative pi over 2, pi over 2. Cosine is considered to be defined between 0 and pi, taking its values, of course, between negative 1 and 1. And cosine inverse is defined between negative 1 and 1, taking its values on 0, pi. So when I'm asked to, let me also remind you of the tangent. Tangent is defined parentheses, not brackets, negative pi over 2 to pi over 2, and it takes anything. And tangent inverse takes anything, but it must return between negative pi over 2 and pi over 2. As we know, the inverse function works. Now, coming back here, I can apply cosine inverse to a number between negative 1 and 1. Okay? But obviously, I have to give as a result an angle in the second quadrant where cosine is negative. So looking at the second quadrant and remembering that which angle has cosine 1/2. And it's not the tiny one. It's the last one. Yes. So it's pi over 3. So this is the angle whose reference angle RA is pi over 3. Which angle are we talking about? And you know that this is pi, and you go back pi over 3. And pi minus pi over 3 must be 2 pi over 3. So this is pi, and I go back, pi minus pi over 3. This pi over 3. So 3 minus 2 minus 1 is 2 pi over 3. So this is the answer. The angle whose cosine is negative 1/2 is 2 pi over 3. Okay, one more here. Sine inverse of sine 13 pi over 6. And this is 51. And as we know, when we apply the sine inverse to sine or sine to sine inverse, we get whatever we see. And your answer should be not so fast. And the answer would be incorrect, because 13 pi over 6 is not an angle between negative pi over 2 and pi over 2. So I have to give an answer here. Since I'm talking about sine pi over 3, I have to find this sine. I cannot use the property of inverse functions. So 13 times 30 is 330, 390, right? 13 times 30 degrees is 390. So this is an angle in the first quadrant. This angle, which is 300, and I don't know why I write that. Okay, so then I know that this is now sine inverse of sine pi over 6. And now I can blindly write this, because now I can apply the inverse property, or the inverse function property, the property of inverse functions. But first I have to determine this, because I cannot write 13 pi over 6. Very good. Okay, that's all about this. Let's move on to the end of chapter 6. The review starts on page 484, actually. A typical problem from this section would be something like problem 30. Let me just tell you what I'm looking at. 30, problems 31 through 42. Of course, just one problem, but we can do more, of course. Something from 51 through 54. 59 through 62. 63 to 64, and then we will look at the triangle. Like anything from 67 through 76. Okay, so let's start with a 30. We had similar problems with this one. A pilot measures the angles of depression to two ships to be 40 and 52. So this small one is 40, and this bigger one is 52 degrees. If the pilot is flying at an elevation of 35,000 feet, find the distance between the two ships. So the question is this. Obviously, this is a 90-degree angle. And that's the height, the 35,000 feet. I do not have this piece. I'm going to denote it by y. And I'm going to look at two triangles. I'm going to look at this small triangle, and I am going to look at the big triangle. In the small triangle, I know this angle at the top because it's definitely 90 degrees minus 52. And that's 38 degrees. So I can find tangent. I can say tangent 38 degrees is y over 35,000. The opposite over the adjacent. And then from here cross multiply, and I have y, which is 35,000 times tangent 38 degrees, which I can find in a blink. 35,000 times tangent 38. Okay, now I'm going to look at the big triangle, where this angle now I know is 90 minus 40 degrees, so that's 50 degrees. So now in the big triangle, I will write tangent of 50 degrees, and I will write x plus y over 35,000. I will cross multiply, and I get that x plus y equals 35,000 multiplied by tangent 50 degrees. All I have to do is move y to the other side and plug it in, because I have it. So x is the quantity or the distance that I need to determine. So I have 35,000 multiplied by tangent 50 degrees and minus y, which is 35,000 times tangent 38. It is easier for me to put it in the calculator. This is really a non-issue whatsoever, but it's easier for me to put it in the calculator like this, factoring out 35,000. It doesn't really matter. Okay, so we have 35,000. In parentheses, tangent 50. Close the parenthesis, minus tangent 38. And there is something extremely important, and I shouldn't forget, which is go to the mode and make sure that the angles are in degree. The mode is in degree, because the angles are in degree. So now press enter, and I get that the distance between them, what was the measurement unit? Feet. 14,366.4 feet, approximately. 14,366.4 feet. Find the exact value, so let's choose, which we already worked on this before in chapter 5, but if you'd like to choose another problem from 31 through 42, I'm fine. Would you like to choose a problem from 31 through 42, or we move on? We move on? Okay, perfect. Find the values of the 6 trig functions of theta from the information given. I think that this is also clear, 51 through 58, but if something catches your eye, we can do that. I definitely want to choose a problem or two from 59 through 64. 59 through 64. Which one? Any preference? I want one with x and one with a number in there.
62 and 64.
62 and 64. So let's look at 62. Sine applied to cosine inverse of 3/8. How do I start this? Well, I have to think in terms of the fact that this is this a number or an angle? Yes. So then alpha equals cosine inverse of 3/8. And I have to apply cosine to both sides. So cosine alpha equals 3/8. And then I draw my triangle. It's a right triangle with an acute angle alpha. And I do know something about the sides of this, the measure of the sides. So cosine is the adjacent over the hypotenuse. Then I will find the other leg. Well, this leg will be the square root of the hypotenuse squared minus the other leg squared. Hypotenuse 64 minus 9. So this is the square root of, is it 55? Good. So now I know I'm asked to find sine alpha, and I'm done. Sine alpha will be the square root of 55 over 8. Any questions? Okay, in 64, everything is identical. It's just that we don't have numbers. We have a variable. Same idea. Sine inverse is an angle. So alpha equals sine inverse. I apply sine to both sides. Sine alpha equals x. And I draw my triangle in which I have an angle alpha whose sine is x over 1. X over 1. The opposite is x. The hypotenuse is 1. Therefore, the other leg will be the square root of the hypotenuse squared minus the other leg squared. And now I know what I'm asked to do. I'm asked to find secant, which is 1 over cosine. If it were a cosine, I would have said this over this, but since it's secant, I have to say this over this. And you don't have to rationalize this one. It can stay like that. Now I would like you to choose a problem in which we apply law of sines or law of cosines. So 67 through 76. Any problem you want. Which one? 74. Very good. In 74, we are given theta 80 degrees 5, 4, B, A, C. Let's see what they want. Find the side labeled X or the angle labeled theta. Okay. This is not a right triangle. This is any triangle. And let me refresh your memory on two laws. One is the law of sines, which says sine A over A equals sine B over B equals sine C over C. And the other one is law of cosines, which is A squared equals B squared plus C squared. If I stop here, this is the Pythagorean theorem. But then I have to subtract 2bc cosine A. And I have two more to write. So these are very important laws. Okay. Here I would like to add also the arc length equals r times theta, where theta is in radians. Please remember this one too. And the area equals 1/2 r squared times theta, also in radians, for the area of a circular sector. And also there are two areas for triangle. So the area of a triangle is also AB sine C divided by 2, where A and B are two sides, and c is the angle in between. We also have another formula for the area of a triangle. If you remember, the square root of s minus a, s minus b, and s minus c, where s was the semi-perimeter, the perimeter divided by 2, yes. A plus b plus c. Good, so let's come back to our problem. So if I write sine theta divided by 4 equals sine 80 degrees divided by 5, I'm done, right? Because I will cross multiply. So I get 5 sine theta equals 4 sine 80 degrees, where sine theta equals 4 sine 80 degrees over 5. So I will put in the graphing calculator. Is this okay? So 4 sine 80 degrees, close the parenthesis and divide by 5. And I'm checking again. Yes, it was in degree. Good. Press enter. And I get 0.7878. I know I have to apply sine inverse to this, and I'm going to do it right away. Sine inverse, apply to the previous answer, and I press enter. So it's roughly 52 degrees. So sine theta equals approximately 0.7878, and so on and so forth. And theta, after I apply sine inverse, is approximately 52 degrees. That's what we were asked to determine. Do we need another? What about 79? Find the distance between points A and B on opposite sides of a lake from the information shown. Let's also look at this. 79. And they are giving us 42 degrees, angle C, 5.6 miles, A, B. They want us to find this distance, and this is 3.2 miles. Law of sines will not work here. Yes? Sorry. Okay, so we're asked to find x. Law of sines will not work here. Why? Because sine 42 over x equals sine a over 3.2 and equals sine c over 5.6. We have variables all over the place. So therefore, I have to use law of cosines. And I will write it like this.
And that's also, I mean,
The side angle side?
right?
Yes.
Okay.
Very good. So this is x squared equals 5.6 squared plus 3.2 squared minus 2 times 5.6 times 3.2 times cosine 42 degrees. And of course, when I put it in the calculator, I will put that whole thing with a square root on top of it. So 5.6 squared plus 3.2 squared minus 2 times 5.6 times 3.2 times cosine 42 degrees. Make sure again your calculator is in degrees. So let's do that. So I have the square root, and in parentheses 5.6 squared plus 3.2 squared minus 5.6 times 3.2 times 2 times cosine 42. So 2, 5.6, 3.2, cosine 42. I think I'm okay with everything. So I got 3.86 miles, 87, approximately x 3.87 miles. So this was about law of sines and law of cosines. And the last chapter is 7. We can go back to any of the other chapters anytime. Let me see how I'm on time with the video. Yeah, I'm gonna stop it here. Hold on just 1 second.